Sorry about that. We're going to look briefly at some organic reactions, some very simple ones. We'll look at a couple more later in our functional groups, but I just want to go over, in general, what kind of reactions you would expect to see in this organic class. So one of the ones are addition reactions. And in those, you need a double or a triple bond, and that double or triple bond is broken, and each carbon at the double bond gets something added to it. That's addition. There are also elimination reactions. Okay, elimination reactions occur when something from two different carbon atoms is taken away. So here we have an alkane, okay, like so. Under certain circumstances, I can lose this, and I get an alkene. Oops, not a triple bond, but a double. An alkene out of that because each carbon lost some part of its things that it was bonded to. And then there's a substitution reaction. Okay, substitution reactions happen when one thing is substituted for another. So we have some long chain here with a group that's an alcohol, but we haven't looked at that yet, and another sort of chain with the chlorine at the end. Now, what's going to happen is this hydrogen is about to be substituted, and so is this chlorine. And notice that this part of the molecule that we were just looking at, let me do that in a different color, this is now substituted in the place of what used to be a hydrogen. That's a substitution reaction. Okay. Sometimes these are synthesis reactions, or they're often synthesis reactions. And notice that we got one thing from each of the two different parts in order to make this substitution. So I want to talk specifically about some reactions. Okay, alkanes, for example. Now, we've looked at combustion of alkanes, and we know that it can be combusted. So, for example, we can take some standard sugar, C6H12O6, and we're going to end up with oxygen, and we're going to end up with CO2 and H2O. All right, so we've done these combustions over and over again. We could also take CO2 and H2O, and using a plant, of course, or something, we can synthesize from carbon dioxide and H2O. So we've mostly practiced or looked at combustion, but we could also have thought about the synthesis reaction. There's also substitution reactions, so that I can take a simple methane, and using the right technique in the right environment, I can take chlorine and add it to make a CH3Cl. And notice that I substituted one of the hydrogens and got a chlorine, and then my leftover product is HCl. The other thing you can do are elimination reactions. Elimination reactions take an alkane and you end up forming an alkene. You could form an alkyne as well and some hydrogen gas. So this particular one is called dehydrogenation, but we could have dehydration, not dehydrogenation. We could have a number of other kinds of structures. Now, for alkenes and alkynes, okay, this has a double bond, and pi bonds are weaker than sigma bonds. I want you to notice we're not talking about the double bond. We're talking about the parts of the double or triple bond. Pi bonds are weak compared to sigma bonds. Okay, so that allows at this double bond that allows an attack to occur, and you can make substitution. I mean, you can change things around. So in this case, when we take a double bonded carbon and some XY, notice that we end up getting an alkane type of situation, except, of course, we have something. We don't know what X and Y are, but it's still all singly bonded again, and we broke that pi bond. If we add certain things, for example, we could add hydrogen. In fact, let's just do that. Let me see. What if we take CH2 double bonded to CH2, and we could add hydrogen to this, and we end up with CH3, CH3, a hydrogenation. We can also take H2O plus, oops, I forgot this, oh, there it is, plus our alkene CH2, CH2 again. And in this case, we would end up with a CH3. Okay, so I'm adding a hydrogen here. This hydrogen goes up, bonded to a CH2OH. So essentially what's happened is, in the water, this broke off from here, and one OH group is added here, and a hydrogen is added on the other side of the double bond. And that's called hydration. Hydration. Halogenation. So let's take Cl2 plus our double bonded molecule. That's going to end up giving us CH2Cl, CH2Cl. Okay, a halogenation. So in this case, we added a chlorine to each side of that double bond, making it a single bond. Now, aromatic hydrocarbons always undergo a substitution reaction. They don't undergo an addition reaction. So remember, we have a carbon here and one hydrogen. Well, when we get the carbon at that site added to a chlorine under certain circumstances, instead of having a hydrogen at this site, we now have a chlorine that's substituted, and we get an HCl as part of our products. Now we're going to look at oxidation of alcohols in a little while, or in another lesson, as well as synthesis of esters. Okay, so I just want you to be aware that those are coming up, but we're not going to look at them right now. And so you might be asked to look at certain reactions and decide what type of reaction it is. I don't especially expect you to decide if it's a hydrogenation or a hydration or dehydration. I want you to say it's an addition, an elimination, a substitution, those kind of things. So when I take this propene, 1, 2, 3, one propene, and add water to it, I end up getting a structure that looks like this, where I have a hydrogen on one, like it was before. It was already there, and added to that is this OH group. And I once had 2 hydrogens down here, but now I have 3. Okay, so what is that? That's an addition reaction. Addition. What about if I take ethane, and I use the right laboratory circumstances, and I end up with this molecule? What did I do here? I eliminated, this is an elimination. I eliminated this hydrogen, and I formed a double bond. Given in the right circumstances, I could even form a triple bond. And in this case, what have I done here? I've taken an alkane and I've added a bromine to it, and this is a substitution. A substitution. Okay, so you should be able to recognize these types of reactions when we start looking at our functional groups shortly.